All right, so I had a couple homework requests from the 8.4 day 1 and 2 homework. I had an email about 27, 28, 31, and 35. So I'm going to do 27, 31, and 35 because 28 is almost exactly the same as 27. So for 27, first of all, in the book, they give you the two formulas up here. These are the same that should be on your formula sheet. We actually only put this one on the formula sheet. You can use the other one if n is 1, but I think we'll just stick with that one. So in the problem, it says you plan to save for a sabbatical to earn a master's degree. You deposit $2,000 at the end of each year, so that would be our P value is 2,000. The end of each year into an annuity that pays 7.5% compounded annually. So at the end of each year and annually tells us that n is just one time per year. Our rate changed to a decimal is 0.075, and how much will we have saved at the end of 5 years? So T is 5. So we should go ahead and then plug those into our formula. So we're plugging those into our formula. So once we have that all plugged into our formula, we just go straight to our calculator. You just want to make sure you're using parentheses appropriately. So 2,000. You'll use 2 parentheses instead of that bracket in the formula. Make sure you arrow out of the exponent before you put the -1 and close the parentheses. And we'll put a division bar to represent this big division bar. And we'll hit enter. 11,661 and 78 cents was my answer for part A. Part B asks us to find the interest. Remember, the formula for interest is to take that A value, our future amount, minus the quantity of our deposit amount, which is P, times the number of times we deposit, which is N, times the number of years we're depositing. So this A value gets plugged in, 11,616.78, minus the quantity of 2,000 times 1 times 5, which will get us 10,000. We then subtract those and we find out that our interest was $1,616.78. Again, I'd like you guys to try number 28 on your own, as it is exactly the same, just with different numbers in the given. I will take a look at 31 and 35 though, because they were a little bit different, I guess. Still very similar. So this one says to offer scholarship funds to children of employees, a company invests $10,000 at the end of every 3 months. Every 3 months would be 4 times a year, which is quarterly. So we should have P is 10,000, N is 4, and our interest rate is 10.5%, which is really high. That is 0.105. How much will the company have in scholarship funds at the end of 10 years? So that would be T is 10. And this actually is the same formula as the last one. Occasionally you'll have to use the other one, P equals, but plug straight into that formula and then go straight to your calculator. You want to make sure you're using your graphing calculator and not your cell phones on this, because there's too many numbers and too many parentheses. That's why I put a link to the graphing calculator app that you can download if needed. You should get $693,030.84. Part B, same question, find the interest. Again, formula for interest is to take that A value we just found and subtract our deposits, which is our P times our N times our T. So that should be minusing 10,000 times 4 times 10, which is 400,000. And when we subtract those amounts, we should get $293,030.84. And the last one I had questions about, which was 35. 35 says, how much should you deposit at the end of each month into an IRA that plans to pay 8.5% compounded monthly to have $4 million when you retire? So this is a future amount that we want to have. 4 million is in the future. So that is actually our A value. Our N value is 12 because it says the end of each month compounded monthly. Our rate is 0.85. And our T is 45 years. So in this case, we're actually using the other formula that you learned in the notes, on the day 2 notes, which is the same formula but solved for P instead of solved for A. And it looks like this. Again, this will be on your formula sheet. And we plug in our values. So we should have 4 million times 0.085 divided by 12 in the numerator. In the denominator, we have 2 parentheses, or a bracket and a parenthesis, 1 plus 0.085 divided by 12, all to the nt power, 12 times 45, and then minusing 1. Again, you just want to take time to punch this in your calculator properly. Again, once you get to the denominator, you need 2 parentheses. Don't use a bracket. So parenthesis, parenthesis. Make sure you arrow out of your exponent before putting your minus 1. Should get $640.75. And that is how much you're depositing every month, so that you'll have $4 million when you retire. Second part of the question again says how much of this comes from interest. So using that I equals A minus PNT formula. So our A value was actually given to us this time. So 4 million we'll plug in there. The P value is what we found in our last part. Our N is 12 and our T is 45. You can type this whole thing in your calculator if you want. I always do this part first, but you don't have to. So I'll multiply those all together to get $346,005 and subtract. So we are earning $3,653,995 in interest. That's a lot of interest to accrue. But again, that's over the period of 45 years, and we do have a pretty decent interest rate of 8.5%. Hope this helps.